Entonces, the famous center of mass. Let me recall quickly the formulas. The formula for the center mass is x, y hat, and z hat of the center mass is the division one quantity que is called momentum, moment, yz divided by the mass, moment xz divided by the mass, and moment xy divided by the mass. And the formula, well, the mass is easy. The mass is, is the triple integral, because it's a solid, and the solid bounded by this surface of the density function, x, y, z, dv. Ese es mass. Ahora, momentum, for example, momentum xy is the triple integral and the same solid, the same bounded, by your multiplication by z, que is the opposite letter of this. xy, z, because of the distance. Okay, the distance. Multiplication by rho. Likewise, I don't want to copy because it's the same thing. The other momentum, no? El momento xc multiplied by y, que es the variable que es missing, no? And yc multiplied by x. Cool, no problema. Esas fórmulas. Esa fórmula, ¿es okay, no? We discuss in one moment that formulas. Okay, this is not important. This is a formula. You have your notebook. Now, the important is understand the solid. Understand the solid. What is that? Surface. And what is that? Surface. And how look like our solid? Help me. Number one, surface is. Number two, surface is. Help me. Any help? In the review, I need more participation. I see the student que participate, the student que understand very well.
Paraboloid and cone.
Paraboloid and cone. Very well. Ese paraboloid. Who are you, mister?
Math.
And it's a cone. Entonces, this paraboloid open up. This cone open up. Makes sense, right? And in one moment, both figures intersecting like that. Okay. Actually, I did my best. 3D is a mess, roughly sketch. So the solid is, for example, let me try, is like above the paraboloid and below the cone. Look like one cup, but this cup is weird because the interior face is conic, but the exterior face is paraboloid. Do you understand the idea or not? No? Confused? Do you understand the solid or you don't understand? Because the most important is you understand. I understand. Okay, it's Max again. Max is the only student que talk to me. Let me open one. Okay, there you go. Look, I create to understand much better one script in GeoGebra to illustrate this idea. Do you see GeoGebra? Yes or no? Okay, in this sketch in GeoGebra, I have a cone, look at that, double cone, and we have a paraboloid. Okay, open up. However, my solid is formed by two surfaces. This one is a paraboloid, and this one is a cone. So you understand that it looks like a cup, but the interior part, interior face is conic, is linear, something, and the exterior is parabola, square. Make sense? Yeah, you follow me or no? Cool, Alba. Good. Now, using my common sense and my imagination, remember the idea for the center of mass as a point, and what you consider a concentrate all the mass of this. It's like, in this case, the density is constant. So no es variable, es constant. Entonces now the problem is similar to find the centroid, no? Centroid actually, well, it's the same. Centroid is when the density is 1. But since the density is 10, it doesn't matter. It's also centroid. When the density is constant, doesn't matter si es 10, si es 100, si es 1. His point is a coincidence perfect between center of mass and centroid. Ok, entonces es obvio, looking the symmetry of this solid, que the center of mass lie on z-axis. Make sense or no? O sea, es very, David say yes. And it's very useless to find momentum, for example, momentum YZ and momentum XZ. No. The only momentum que I need to compute is the momentum que somehow involve the Z-axis, que es momento XY. And moment and the mass. Okay? So it's important because you spend a lot of time doing this. Compute one thing you suppose physically que es zero, according to the symmetry. Do you understand the idea or no? I have another question. So you understand this, que the center of mass lie on the z-axis because x bar and y bar is equal to 0 physically. And what about z bar? The value of z bar, let me try to understand, is in your opinion, well, I suppose it's in the middle, no? This is 0, this is 1. Because by the way, well, I forgot to say something. Okay, suppose que I want, okay. Let me come back to the whiteboard. You see at least the solid. Okay, cool. Now, okay, whiteboard. You see whiteboard? Would be important to find this face. Okay, actually it's a hollow, no? That part. What value of C? So you put together this equation, for example, in this equation, x squared plus y squared equals C. In this equation, the same stupid thing, x squared plus y squared is equal to C squared. So you have equation, solve the equation, you find the intersecting between two surfaces, no? Entonces es obvio que C squared minus C equals 0. Factorization C squared minus 1 equals 0. Es obvio que the solution is C equals 0, que es that point, and C equal 1, que es this plane. C equal 1. This was interesting to understand at least. Therefore, okay, let me try to complete before set up the triple integral. I need to do one 2D picture. Que in my opinion is most important 2D que 3D. Well, 3D is important, but 2D is super important. For example, one lateral view, suppose XC. And why no? We are doing another XY. So full plan and lateral view. 2D, 2D. And the first 2D, we have a cone. We have a paraboloid, approximately, and this is my solid. I discover somehow that this level of the C is 1. Look at that. Now, when you projecting this to this, it's obvious that we have a circle. And the circle is obvious that the radius 1. Center and the origin, radius 1. 1, 1, negative 1, negative 1. Everyone follow me? Yes or no? Cool. Therefore, I am ready now to apply, for example, to compute the mass. Triple integral. 1, 2, 3. The integral function is constant, que es the density, que es 10. Entonces, I make a decision to apply, of course, in my opinion, the best way is cylindrical coordinate. And remember, cylindrical coordinate, the variable is R, well, either way, is Z, for example, comma, R, comma, theta. Like it's part is a polar, no? It's part is a polar. And you decide another component, like a Cartesian or rectangular. In this case, obviously C. And C go from, for example, when you integration DC first, you go. I go to the 3-dimension picture. Okay, I go from the paraboloid to cone. Another point of view to see more clear, I go to the paraboloid to cone in that direction, C direction. This idea is correct. So the first level of the integration is DC. And DC go to the C value paraboloid to the C value of the cone. Right? But C value of the paraboloid is x squared plus y squared, and another is x squared plus y squared plus square root, no? Entonces, actually, I cannot. See, I make a decision to change to cylindrical. X and Y, no, participate in the game. Participate R and theta. Entonces, this go to the C equal R. Look at the equation. In the equation, see, in my mind, I replace bipolar. This is R squared equal Z. And this is R squared equal C squared, que es equivalent to say R equals Z. So I go from the paraboloid, que is R squared, to the cone, que is R. Make sense? Make sense? Make sense? Yes or no? The rest is easy. The rest is elementary. The rest is the Jacobian, que es RDR. ER go in this view you see clear from 0 to 1. And the data is easy because it's full circle, entonces from 0 to 1. Okay, I want to skip, as always, the computation list. You're using, I don't know, by hand, Wolfram Alpha. The answer is 10 pi over 3. Okay, this is a mass. Well, entonces I suppose que you understand very well that this is completely useless computing momentum YZ and momentum XZ because it's 0 according to the symmetry of this figure. Then my goal is compute the momentum XY. Okay, the formula is triple integral again. And here we have 10C, because the variable que participa is C, and the rest is the same. DC, RDR, deta. And the limit is the same, because it's the same solid. R squared, R, 0, 1, 0 to 1. It's similar, but now includes C in the first stage of the integration is C. And the answer is the answer is 4 pi over 3. Okay, now entonces the Z hat of the center of mass is 4 pi over 3 divided by 10 pi over 3. And so because pi is cancelled, 3 is cancelled, stay alive only 4 over 10. Reduce the lowest term to 2/5. Okay, entonces what is the conclusion? What is the conclusion? Where is located the center of mass of this solid? Well, the center of mass of this solid, center of mass, is located at the point 0,0,245. That makes sense because suppose according to the symmetry, we can suppose that the center of mass is located in one specific point on the z-axis. It's obvious que it's in between 0 and 1, no? But exactly in the middle, in 1/2, the answer is no. Because that part, in my sketch, maybe it's not clear to see. That part is y is and y is. Because to find, okay, this is a little bit complicated to explain, but it's a formula. It's a formula. So in the formula, when you want to find C hat, is triple integral, triple integral of the C rho dv divided by triple integral rho dv. Esa es la fórmula. Now this is momentum que they call xy. That C do not participate in the notation, but participate in the integral because it's a C we want to find. Okay. But the thing I try to explain is look in the. Let me try to show you in GeoGebra, no? Let me try. Here, over there. Okay. Look. So the analysis I try to understand is, this is my solid, no? Okay, entonces en the solid, you see que the center of mass is a little bit below to the 0.5, que es 1/2. So it's on the z-axis, but a little bit below. Because the figure, the bottom part is wider than the top part. This part is greater than this part. At the center of mass, I plot that. Boom. Look at that. This is the center of mass. The center of mass is, look here. 2/5 gets 0.4. Makes sense, right? Guys, it's important when you are engineer and you compute something, you try to verify mentally. See the thing you compute make sense or no, or is it stupid? That part is wider than that part. Therefore, the center of mass is a little bit, not too much, but below the 0.5. It's clear? No? Please, go ahead.
Why is the momentum and the x, z, and the y equal to 0? Is that because it's the center of mass is along the z-axis?
Yes, yes, yes. This is the idea. According to the symmetry, we have no distance. Okay, when you perform this integral, consider it, for example, x or y, the answer is 0, according to the symmetry of the figure. Okay. Guys, you need to take one specific subject. It's called static, in which you see clear everything. This is my duty. Duty is to create the foundation for this subject. So, but they are very important subject in engineer, in which calculus 3 support fluid mechanics, electromagnetism, que is the part of the vector field, que is the chapter 4, and the part of the static is center of mass, centroid, something, momentum. Okay, this a little bit clear or no? A little bit, no. Okay, my goal is identify the solid, apply the formula, and that's it. Okay? Question. No was clear my explanation. Mister? No, clear, okay. Okay, so let's start review, but slow down. I need to get you understand 100%, 150%, everything. Okay, we have, you see I sent this email 2 pages in PDF, get the review. Okay. Some question we are doing here, some question no, but I want to repeat now. The detail now is, okay, I compute by hand everything. Exactly I need that you are doing. Okay, suppose the question number 1. The question number 1 say, evaluate by changing the order of the integration. So one integral is given. I need to understand the idea behind this double integral. How the student can doing setup this integral apply and you change the order. So it's given in this. Okay. So now I can see clear that the guy can set out this double integral is doing dy first. That limit is y equal pi, y equal x. So y I write like an inequality. Very.
We can't see this, the whiteboard.
Oh, sorry. Wow. Now you see?
Yes.
Repetition again. Question 1. Question 1, say. Co-evaluate by changing the order of the integration. This double integral. 0 to pi, x to pi. The integrand function is sine y divided by y dy. Yeah, this is a given. This is a given. The first thing that you should do is understand how the student can set out this integral doing. So I can see, wow, the first level of the integration is dy. Therefore, this is y value, and this is y value. So you set out like a inequality, y vary from x to pi. And also x vary from 0 to pi. Okay, so remember here, you take this like equation, y equal pi. You take this like equation, y equal x. And you are doing the sketch of this curve. Okay, y equal x, let's do this first, easy, line, in both direction. This is easy also because it's horizontal line. Okay. This is y equal x, this is y equal pi. I suppose that we have here a point, que es the point pi pi, no? Because if y pi is y equal x, okay, this is pi, and this is also pi. This is 0, pi, no? And this is pi, 0. Okay, cool. Now, the integration is doing here in this direction. How do you know? Because it's y first. Okay, and open, okay, it's from the x to the pi, yes. And extending from 0 to pi. So basically, the region, okay, this student working before us is that region. This is our famous R. And the goal for this problem is changing the order. Changing the order means que your integration no like that. Your integration like that. Okay. Entonces now I copy the double integral again. The integral function stays the same. No change. But you put dx dy. Now. And the new limit for the first level of the integration case dx go from this value, it obviously is x equals 0, this point, to the x value of the line, que es x equal y, no? Look. But you express it now like from 0 to y. Make sense? This is x equals 0. Something no. The majority of the time I omit this. Because default, you need to suppose que si your integration with respect to x, this value is x value, no? Entonces now you're extending that part from this to this. And when you're extending from this to this, to cover the full region is from 0 to pi. Everyone understand this idea or no? And by the way, the value that I compute now of this integral is exactly the same the value of this. But this is complicated because the antiderivative is 2r, and this is extremely easy. My recommendation is you take the first level of the integration. You copy separately. and you try to do. When you try to do, the integral function depending only on the y. Entonces, and the effect of this integral, I suppose, is constant, similar to the partial derivative. And integration dx with respect to x is x. Evaluate in between 0 and 1. Entonces, let's do it. Evaluate. Evaluate is y here and 0 here. Es obvio que 0 is nothing. Entonces, stays sin y over y multiplication by y minus 0, no? Okay, just y. This is cancelled and the answer so far is sin y. Entonces, with this result, follow me or no? With this result, I come back. Somebody say something. All right. David, follow. Okay. Guy, I see noise. Who make a noise? Diego, who make a noise? Okay. Now, I come back to the original. Entonces you are doing the second integral. You copy now the integral function is sine y dy is the first part, the last part. Entonces antiderivative sine is minus cosine. I know that. Evaluating between 0 and pi. This minus, I propose you put outside the game. Yeah, evaluate cosine pi minus cosine 0. Cosine pi, I know by memory is -1. Cosine 0, I know by memory is +1. But we have a negative in the front, a negative and negative together is -2, and one negative outside is +2. The answer is 2. End the story. Any question? Easy. I remember I did before this, but this is classical example. So the n is 1 plus 1. Well, no, I don't say 1 plus 1. I say negative, -1, -1. Entonces negative, -2. Positive 2. Any problem with the arithmetic part? No? Typical changing of variable in Cartesians. Guys, this is the review. Therefore, I need to know. So you have a minimum question, a minimum doubt of this part. Everything is super clear, huh? Erase. Okay. Okay, of course, in the test, we have different questions, no? But it's similar objective, no? Question number 2 dice, using double integral to find the volume of the region bounded by the cylinder. So one region bounded by cylinder, x squared plus y squared equal 1. And the plane C plus y equal 1. Wow. It's a plane. Cylinder plane. Make sense, right? Entonces ese volume, ¿no? Si ese volume, bueno, in this case, ese volume, pero using double integral. So remember, it's important that you understand that when you compare volume, using double integral or triple integral, and the double integral, you put here z, CDA, or whatever, f, x, y, dA. And when you compute the volume in triple integral, you suppose that the integral function is 1, dB. Cool? But they want in that way. Okay? But I need to understand the solid first to make some conclusion. I need to understand. To understand the solid, the recommendation is always the same. You try to do the solid in 3 dimensions, explore some view in 2 dimensions. Okay, entonces now let me try to do my best, que always is complicated in 3 dimensions. We have cylinder. Yeah, cylinder is easy. Cylinder radius 1. No restrictions, maybe positive or negative. No, yeah. Sorry, I forgot to say in the first octave. First octave indicate que only positive part. Okay, entonces no that part. No, no. Okay. And the plane. The plane is a little bit complicated. No, it's not complicated. It's C plus Y equal 1. Entonces X is missing in this plane. Let me try to do my best here. In order to, entonces I complicate, I try to do here because I don't see very well. I do the graphic of the plane. The plane is look. For example, one fantastic way to do the graph of the plane quickly is compute the intersecting. Suppose que Y is 0. Let's see 1. And we have 1 point here, get the point 0, 0,1. No? And like Y, you suppose que C is 0 and Y is 1. And we have the point 0,1,0. And at least I have a line. But remember, X is missing, so this plane is along the X-axis. The plane look like that. And the cylinder look like that. More clear? More clear? Of course, the plane is infinity in any direction, but the plane is somehow intersecting with the first octave is that part. Okay, so now let's do it together. When you are doing together, let me using another color. This is 1, this is 1. We have here intersecting, right? And this is that part. Okay. Now you see my common sense. Okay, the most important most important than the knowledge is the common sense. My solid is formed by this part, this H, that H, that H, and that H. Okay, that H, I try to connect any corner, no? This is my solid. Look. It's formed by one lateral wall, and this is the roof, the top part. The top part is the plane. The top part is the plane. And the lateral is the cylinder, no? Cylinder in one part. And another part is the plane formed by the ZY axis and the ZX axis. Okay, it's the corner of the first octave. So I did my best in 3D. Let me try to understand. I try to do my best in 2D. In 2D, remember we have 2 possibilities for plan and lateral view. Not necessarily do. See, you get the idea, enough information to set out the double integral, you don't need to do another view. Entonces, en my opinion, this for plan is that part. Look at that. That part. Que es a quarter of circle, no? A quarter of circle. Quarter of circle, 1, 1, radius 1. Everything is 1. The cylinder is 1, the plane is 1. So this is my region. This is my region R, in which you set up the double integral, correct? So basically, the thing is double integral in the region R. I need the specification, the integrand function, que in my opinion is the C value of the plane. So this is the height. Okay? Of course, it's no constant, it's variable, but it's C. It's C. It's C. So here I copy the Z. This Z I copy. I copy the. Okay. C. Bueno, C is equal 1 minus Y, no? I copy this inside the box. What is the reason I don't copy? I don't copy because, in my opinion, it's much better doing by bipolar, no? So remember, when the region is circle, semicircle, quarter of circle, it's super easy doing bipolar, no? So you're doing by Cartesian, you complicate your life. No, it's impossible, but it's hard. Okay, so now basically, this double integral, I convert to polar. Entonces, en polar, I put the Z. Okay, the Z, pero express it using polar variable, que es R theta. Yeah, I know very well que Y is R sine theta. The integrand function transformed from Cartesian to polar is 1 minus R sine theta. R dr, the Jacobian integral. Entonces, this is super easy. The integral here go from 0 to 1 in R. The integral go from 0 to pi over 2. End the story. Do you understand very well? Okay, David. But in the review, David, we are doing everything by hand. Of course, we can check it with the calculator or Wolfram Alpha. So I recommend, I highly recommend, okay, you are doing everything. Let me try, for example, I do some problem, not too much. Using this problem, I suppose I did in Wolfram Alpha. Let me try to show you something. Image, my device. This is question 2, no? Look, I did that in Wolfram Alpha. Okay, I make a screenshot, no? And this is the answer. But no, I want to do by hand because I want both. I want that you are doing by hand. I'm double checking with the Wolfram Alpha. Okay, not all the problem, but the problem that you consider it complicated, and to make sure. Okay, now let's forget about this for a moment. Let's focus on the integral part. But first of all, I copy the first integral here, 0 to 1. Of course, you multiply, you copy R squared, R times 1, so you distribute it, no? Minus R squared sine theta, dr. Entonces use, bueno, actually it's two integral. The first one is R squared over 2 minus R cubic over 3, and sine theta is considered constant. Do not participate in the integration part. And R vary from 0 to 1. Therefore, so far, the answer is 1/2 because r is 1 minus 1/3 sine theta. And the other is 0. 0 is 0. It's nothing. So I copy the second integral by plugging in that new integral function and your integration with respect to theta. It's doing. Well, the first antiderivative is 1/2 theta. Because it's a constant, ¿no? Entonces integration theta with respect to theta is theta. Plus or minus. Es bueno, antiderivative sine is minus cosine. But we have a minus and become positive. So 1/3 cosine theta. And everything evaluate in between 0 and pi/2. Okay, it's doing. So it's pi/2 here, it's pi/4, because 2 times 2 is 4. Plus 1/3. Well, no, wait. Cosine, cosine pi/2, no? Pi/2. So you evaluate here pi/2. You evaluate here pi/2, no? Okay, cool. Minus 0 over 2 plus 1/3 cosine 0. Well, cosine pi/2, you know, is 0. And cosine 0 is 1. And this is also 0. I stay alive only pi/4 minus 1/3. Fantastic. This is the volume for that figure. Any question?
Professor?
Go ahead.
When you switch to polar and set up your double integral, why do you always put an extra r next to the dr?
This is the Jacobian. Remember, we are doing changing of variable. We have the original coordinate xy, and you change to the r and theta. When you change of variable, do you remember the Jacobian?
Yeah.
The Jacobian is standard. Everyone in the world knows very well that Jacobian and polar is r. R detail. So basically, the idea is, this is a good question. dA, que es dy dx or dx dy, and the polar world is r dr d theta. In this order always. Okay? Cool or no? Understand? Okay. Any other question? Is a smart question like that? This is a moment to solving any questions. Okay? No? Okay, moving on to number 3. Number 3 say.
Professor?
Just
one more, but the reason you got your bounds for theta, d theta, was because it was in the first octant. That's why you went from 0 to pi/2?
Let me see. Oh, yes, you're right. Yeah, pi/2, no? I put 2 pi or put pi/2?
Pi/2.
You understand why, no?
Because it's the first octant, right?
Yeah, absolutely. Remember, in the 2-dimension view, you see the solid is like that. Remember, right?
Yeah.
Entonces now, remember, in polar, okay, Cartesian is something like that. It's a square, dx, dy, and when you integration, the action for the integration is you stretch it like that or like that. And polar, no, and polar look like a piece of cake. A piece of cake, right? A piece of cake, not exactly a piece of cake. Let me see. And polar is something like that. And this guy is d theta. This r length, this r, and this is the r. So now when you have here some figure like that, and you are doing the integration, and you extending from 0 to 1 the R bar. When you open the piece of pie here, you extending from 0 to pi over 2. Make sense? Make sense, guy?
Clear.
Yeah, this is the magic. This is science fiction of the integration. Okay? Okay. Let's move on to the question 3. Question 3 is easy, it's similar to question 1. Let's compute the double integral. Okay, is evaluate the integral by reversing the order of the integration. Again, the same problem. This doesn't look like important. Reverse the order. Okay. Number 1, to do anything, understanding the region. I saw okay, we have one level of the integral is dx first. Therefore, x vary from 3y to 3. And, well, y is easy, is constant, 0 to 1. With this piece of information, I try to do my best in the graphic to understand the region and understand the direction okay, another guy is doing setup this double integral. Yeah, I want to reverse it, this order. So you take, for example, this equation, x equal 3. Oh, it's a vertical line. Okay, 1, 2, 3, vertical line. X equal 3. And you take this equation, okay, is 3y equal x. You convert to equation always, guys. Get the boundary, no? Now, I'm not good for this. I prefer isolate the y. This is x over 3. Oh, it's a line passing through the origin. And its lowest 1/3. See, the lowest 1/3, wrong and right, look like that. This is the line y equal x over 3. Entonces, the direction of the integration this guy doing was from the line to the vertical line. No? So the line can set up this integral is doing in this direction. Or horizontal direction because it's x. No? I want to change. I want to change to this direction. Okay. Okay, this is my region. So identification the region is somebody doing this integral. This is my famous region R. Identification also the direction of the integration okay, was the blue, but I want to change to the red color. So I set up my new double integral. The integrand function I don't touch, but I reverse the order of the integration. Okay, entonces I go in the red direction. I go from y equals 0 because this is my first integral, and my first integral the value here, the limit is y value. No? Entonces it's from y0 to the y of the line. It's easy because 0 is 0 and the y of the line is x over 3. I did before, I isolate the y. Okay, now when you extending the red part to this direction and this direction, so you open the window horizontally now, I go from 0 to 3, no? To 3, excellent. Entonces from 0 to 3. And this integral is the same, so have the same answer The orientation is different, however, the answer is the same. Cool? Any question in that part? In my opinion, this is most important. The rest is stupid calculus 1 and stupid algebra. But we need to do, of course. Okay. So now I recommend doing step by step. Iterate. Iterate means step by step. You copy separately here. 0 to x over 3. E to the x squared, and you integrate with respect dy. Oh, it's easy because that part is not depending on y. You consider constant and you put outside the game. And you integrate dy with respect to y, evaluating between 0 and x over 3. Entonces es ex squared, x over 3 minus 0. And so far we have x over 3 e to the x squared. Yeah, I copy this, I put in the second integral. Second integral is from 0 to 3. I just copy 1/3. 1/3 is the constant outside, x e to the x squared dx. And this is relatively easy. Compute that because by elementary substitution, suppose substitution, in which you consider the u is x squared, no? Entonces now, the u is equal to x dx. The only thing I need is extra 2 here to complete the differential, and you put here the 2. 2 divided by 2 is 1, so it doesn't affect. However, this is 1 over 6. Integral e u du. Because this guy and this guy together is the u, no? And this is u. And the limit stays in no, the limit change, you know that. 0, you evaluate 0 in x equals 0, u is 0, and 3 is 9, because it's square. This is super elementary. Antiderivative e to the u is e to the u. Evaluating between 0 and 9. The answer is 1 over 6 e to the 9 minus e to the 0. Okay, 1 over 6 e to the 9 minus 1. Boom. Final answer. Any question? Any question? Let me see the big picture. Any question? So far, we have 100 points in the test. Yes or no?
Yes.
Excellent. This is my goal. My goal is that everyone get 100. So you are lazy. It's your problem, not my problem. But at least I try to do my best. Always, I try to do my best. Sometimes no. Sometimes I fail because I am human, no? But the majority of the cases, I try to do my best. No question? Erase? Okay, cool. Let's move on to number 4. Number 4 question is nice. I like that. Okay. Number 4 is say, evaluate the integral by converting to polar. Okay, nice. Converting to polar. Number 4. The integral is integral from -3 to +3. 0 to something. Wow. 9 minus x squared. Sine x squared plus y squared. dy dx. Okay, because I need to understand. Okay, the first level of the integration in this double integral is y. Therefore, the y vary from 0 to square root 9 minus x squared. Okay. Therefore, as always, I take this like equation, y0, and y equal square root 9 minus x squared. But I don't like that way. I like you square both sides because I want to eliminate the square root to understand much better. I try to express it in standard. I can see clear like water that this is a circle with a radius 3. So doing this idea, using this idea, I try to do my best in order to understand the region that some guy set out this integral. Bueno, I say que y equals 0 is the x-axis, and we have a circle, okay, the radius 3, no? Cool. However, my question is a full circle or a semicircle? Well, I suppose it's a semicircle. Why? I suppose because in the square root, I have no double sign here, plus or minus, no? See, I have no plus or minus, it's because default, I suppose, que es positive. Entonces, actually, the difference between this equation and this equation is that this represents a circle, full circle, but for me and my eyes, it's easy to see it as full. However, it's actually a semicircle. A semicircle. A semicircle. The confirmation, well, the confirmation, no. This is the region. Semicircle. Semicircle. Okay. This is my region R, in which some students set up this double integral. And these students are doing like that. Okay, dy first from 0, que is the x-axis, to touch the upper part of the semicircle. Is this positive? And finally, he or she is standing in both directions, from -3 to +3. Oh, I understand very well now. But what's my goal? My goal is chain to bola, no? Okay, this is my goal, chain to bola. I need to do everything now to convert this double integral in another double integral equivalent 100%, but in polar. Okay, so we need to do something. We need to do something. Number one is, well, convert the integrand function en polar. O sea, no x squared plus y squared anymore. No. It's a Cartesian. It's sine r squared. Sine r squared. Cool. Because I know very well que x squared plus y squared is equal r squared. Sine r squared. Don't forget the Jacobian part are the r and the theta, because we are doing changing the verb from Cartesian to polar. And when this situation happens, the reason, the physical, the logical reason, the Jacobian is that we have a scale factor. So the area and what part I consider that the integration is like that or like that is not equal when I suppose that the integration is like that or like that. the scale factor. They are a scale factor, and this scale factor is RD. Okay, cool. Entonces now it's easy, super easy, because in polar I go from 0 to 3, no? The radian, always 0 to 3. And theta open from 0 to pi. 0 and pi, not 2 pi. 2, when you say 2 is 2, not 2. Okay, 2 pi. Ready. And this is super elementary, straightforward. Integral, because the limit is constant, number 1. And number 2, the variable is completely separable. So you separate this integral and two integrals. Not always is possible doing that. Well, it's possible when the limit is constant. Multiplication, and you separate sine r squared r dr. Okay? Separate variable, the integrand function, r and theta, you can write separate, and the limit is constant. So now it's no iterator anymore. No, it's 2 multiplication separately. And this piece, okay. The answer of this part is pi. It's obvious because the antiderivative theta is theta, and between pi and 0 pi. And this is also relatively easy. It's doing by substitution, similar to the other case we are doing before. I assume the substitution que u is r squared, therefore the u is 2r dr. Sorry. We need to complete differential. We complete extra 2 here and divide it by 2. Okay, so basically, let me copy. This integral, 0 to 3. Sine, I copy separately, guys. It's a good idea. When the mathematics is super complicated, we copy one piece. You copy in one piece, in one corner of the piece of paper, you solve it, and you copy and paste in the original place. Okay, so now, the substitution was, I need extra 2 here to complete differential, divided by 2 here. Cool, so we have 1/2 integral. Remember, the substitution was u is r squared. Therefore, we have sine u, the u, no? Because 2r dr is du. And the limit, well, the limit is, again, is 0, and 9, no? 0 and 9, because 0 squared and 3 squared. And the derivative sine is minus cosine. Entonces, minus cosine, 1/2. Don't forget the 1/2. Minus cosine, or either way, minus cosine u. Evaluating between 0 and 9. Entonces, negative 1/2, I consider it in the front. Cosine 9 is 9 radian, no degree. Minus cosine 0. Cosine 0 is 1. Entonces, therefore, my final answer is negative 1/2, parenthesis, cosine 9 radians, minus 1. Bueno, I put in more elegant way. Que is 1/2 positive, 1 minus cosine 9. And then the final answer, no, don't forget the pi. Don't forget that pi, no? The final answer is multiplication pi times this. That's a pi over 2. Parenthesis, 1 minus cosine 9. Boom. Final answer. Any question?
Professor, I understand how you got the limits for d theta, but for dr, I understand that the upper limit of integration is going to be 3, but why is the lower limit 0?
So the thing you don't understand, why is 0 here?
Yeah.
Because in the world of the polar, the radius go, remember, and polar is the black part. Go from r equals 0, que es the origin, to r equals 3. And the word of the x, I go from -3 to +3. And the word of the y in this problem, no, I go from 0 to 3. That is the reason that it's first quadrant and second quadrant. But in the word of r, I go from 0 to 3. Look, from 0 origin to 3, to touch any point, 3 units in any direction.
Oh, even at the bottom, it'll still always be 3.
Yeah. No. And this, okay, I focus in my example. I don't want to generalize. No. I take the original double integral is given. I investigate the region. I highlight in yellow color. I want to know to convert this integral original and double integral and polar. So I focus in my new region R. My new, no, the region que es given at the beginning, no? The guy que spend time doing this double integral and Cartesian doing in the yellow region, no? Entonces my radio go from the 0 to 3. This is clear the idea, David? Es David, no? O es Teo?
Clear, it's Max.
Es math, okay. Okay. Don't allow intimidate with me. No. So you don't agree with me. You say, Professor, I don't understand because I believe you. I respect any opinion. You are young and you are super smart guys, and you are the future of this country. Okay, so now you apport your idea. Maybe we are human and make a mistake, no? You make a mistake or I make a mistake. I accept that I make a mistake. I make a mistake every day because I work in mathematics every day. Entonces es obvio que you and little by little become old, no? Getting older. Now, sometimes I forgot the negative sign to say, you know, the mathematics is horrible. The mathematics don't forgetness anything. So you omit one sign, the answer is different. So say you get the wrong answer. No, but okay. Suppose you are doing 5 pages doing the integral, and you say in the last moment of the page que 2 plus 2 is 5, no 4. Entonces you get 0 point. No, hello. Okay. Cool. Number 4. Let's move on to number 5. Number 5 say, evaluate the integral by converting polar again. Okay, polar. Polar is important in the test, I suppose. Number 5. Entonces the integral number 5 is given. The problem is 0,1 y square root 2 minus y squared. Integral function is x plus y. And the order is dx first, dy second. Okay, remember step by step. Understand the region, understand the direction that this guy can set out this integral doing, and you change to polar. It's the order, yeah, away. Okay, yes, sir. Okay, so now I see that the first integral is dx. Therefore, x vary from y, is this, to the square root 2 minus y squared. Y ahí separé la equation. Y equal x, it's line, good. And the second is x equal square root 2 minus y squared. Entonces maybe I need to manipulate a little bit to understand much better. I believe que es the circle, but I don't understand. Square both sides, put x squared is equal to minus y squared. Okay, nice. Therefore is the x squared plus y squared equal to, oh, it's a circle. It's a circle with the radio 2. When I try to do my best, I do the rectangular coordinate 60 by hand. I know that one bound of this problem is a line, the famous line y equals x. I have a circle radius 2. Suppose one, no, radius radical 2. Sorry, the radius is radical 2. It's a square root that guy. Okay, 1.40 something. The radius is radical 2. Boom, something like that. Well, entonces now, and the y value vary from 0 to 1. Okay, the last limit. Y. But, okay, actually, this is a fourth circle of the half of circle of what part, the top, the bottom, the right, the left. What do you think? And also, let me try to identification my region. I need to identification. So the guy que set out this integral, let's do it in x direction first, and go from the line to the circle. I suppose que this direction. But let me do it again. Using blue color. Okay, it's important to understand that this equation represents circle, but one portion of the circle, okay, is this portion, the x positive, when the x is positive. So this give me a clue, a little bit, what part of the circle it is. So let me try again. Okay. Entonces the guy doing the integration doing in this direction. He of course open the window vertical, up and down. I suppose. This is my region. Make sense, guy, or no? Don't accept anything I explain. Do you understand the region? R? Clear. Region R. My goal is now change to polar. Okay, let's do it. You change to polar. You write double integral and polar. Let me erase this part, it's not important. Double integral and the region R. First of all, change. So we have different steps. Step 1 is determine the region. Step 2 is changing the integral function to polar. Okay, let's do it. Entonces R, I know that x is equal R cosine theta. Y is R sine theta. Entonces I copy. R cosine theta, because everything I write in this new integral is expressed using polar variable. Never x and y anymore. Multiplication. After, third step is the Jacobian part. R d theta. And the last part is the limit. So I put the symbolic region, but I define my new limit R and theta. Entonces now, see, this is my region. Let me focus in this. Es obvio in my mind que R go from 0 to the radius of the circle. Okay, remember, this is the infinitesimal elementary polar. Okay, look like that. And when you extending, stretching, R first go to the origin, get 0,0 to touch the radius of the circle, get radical 2. By the way. Okay, 0 to radical 2. And R, theta is easy. What do you think about theta, guys?
Is it pi over 4?
Excellent. Pi over 4. 45 degrees. Excellent. Pi over 4.
Professor?
Uh-huh.
It
What do you
just
say?
looks like pi over 4, and that's why I said that. But like, how do we know for sure that it's pi over 4?
Well, I know, because the equation is y equal x, no? At any point you take on this line, suppose 1,1, 2,2, 3,3, no? The tangent is, suppose you want to find theta, is tangent inverse of y over x. Si x and y is the same, entonces tangent inverse of 1, que es pi over 4. But another line, suppose y equal 3x. Bueno, entonces you divide 3x divided by x is tangent inverse 3, you make different angle. Makes sense, right?
Yeah.
Excellent. Excellent. Okay, so now we're focusing on the solution for the double integral. I know this is another subject. This is calculus 2 and calculus 1 and algebra. But okay, it's important to get conclusion, no? Entonces I taking that part separately. The R part, for example. And you copy. You copy how? Well, you copy like that. Okay, you copy, you multiply, why not? R times R, R times R. This actually is R squared cosine theta plus R squared sine theta. Yeah, this is my problem, my piece of problem. Okay, no. Well, no, okay, let me see. Okay, wait, well, I did in my paper a more smart way. Look, the limit is constant. Yes or no? The limit is constant. So I take advantage of this fact. The limit is constant. Entonces, no, okay. Yeah, I multiply, pero different. Look, I multiply, pero different. I multiply like that. This is parenthesis cosine theta plus sine theta. You factor out this r outside. I multiply by other r is r squared. dr d theta. Do you see that? This is the way I see in the moment I did in my paper, no? Okay. Now is separable. So we have one integral que dedicate only for the data, que is cosine theta plus sine theta d theta. Multiplication, another integral que is only r dr. Wow, fantastic, I like that. Entonces now I copy. Bueno, copy no. I separate that part. That part is piece of cake. It's piece of cake because this is r cubic over 3. Evaluating between 0 and radical 2. Entonces radical 2 cubic over 3 minus 0. And this is 2 radical 2 over 3. Bam. I copy the answer for this piece. Let's do the answer for that piece. The answer for that piece is relatively easy because the antiderivative cosine is sine, but the antiderivative sine is minus cosine. Evaluating between 0 and pi over 4. Let's doing. Sine pi over 4 minus cosine pi over 4 minus sine 0 minus cosine 0. Okay, that part is 0. Why is 0? Because I know very well in trigonometric sine and cosine is the same in pi over 4. Radical 2 over 2, radical 2 over 2, radical 2 over 2, radical 2 over 2 minus radical 2 over 2 is 0. And sine 0 is 0. Wow, everything is 0. Entonces, this is 1, no? Cosine 0 is 1, negative 1, another negative become positive. And this is the final answer. Because you multiply these by this. Cool or no?
Clear.
Excellent. Unfortunately, well, time is over. Time is over. We continue Wednesday and Friday the review. Okay. I suppose a good idea, David, and the rest of the students. I will send the test number 3. I will send the test number 3 next time. You have more time to do this, right? So now, my plan was que I collecting July 5th, no? Was my plan. Do you remember or no?
Yes.
You let me say make a mistake. So after the holiday, so you spend the holiday doing the test, no? Sorry, but this is okay. You want to become engineer, you need to work. So I need to change the due date in my lab of the homework and test online to the July 5th. Cool?
Very cool.
So now we finish for today.
Professor?
At
the beginning of class, I wanted to tell you one more thing. It's that there's like one of the homeworks that are like for the integration chapter. It's like homework 13. I think it's supposed to be with the last chapter because it's like supposed to be like how you said there was only 3 homeworks. I think there's supposed to be 4. If you look at it on my math lab later and open the last homework 13, I think it's supposed to be for the next chapter because it talks about the vector fields.
No, vector field. Vector field is this. You see, I make a mistake. I put available. The homework, the vector field, you don't touch.
Oh, okay, perfect.
Because maybe I put available. It's no. It's my bad. O sea, I say que 3 homework, no? Only 3. I don't remember the number, no?
There's 4 homeworks for the integration chapter, and there's 4 for the vector field stuff.
Oh, okay.
It's just you made one of them available for the vector field. Like one of the vector homeworks are available.
Good. I understand. Okay, listen to me. He explained me that we have 4 homework in the integration part, but one more homework is available, okay, the vector field. You forget about the vector field. Vector field is the vector calculus. We start next week, right? After the holiday. Okay, cool, guys. Thank you so much. Have a nice day. Bye-bye.